Okay, so these are the solutions to the classwork today. Today is December 12th, 2011, and we did the first two of these in class, the number 3 and 4, the homework, and I'll put those solutions up on a different video. So number 1, if one leg x of a right triangle increases at a rate of 2 inches per second, while the other leg y decreases at 3 inches per second, find how fast the hypotenuse is changing when x equals 6 feet and y equals 8 feet. Okay, so the first thing we need to notice is that the legs of the triangle are decreasing and increasing. They have a rate, and it's in inches per second, where we're given the side lengths in feet. So we're going to have to convert our legs into inches. So we know first that x is 72 inches, while y is 84 inches. We also know that x is changing at a rate of 2 inches per second. It's increasing, while y is decreasing at a rate of 3 inches per second. So we're going to write down everything that we know, and we realize that we need to find the hypotenuse first before we can find how fast it's changing. So what we can do is we can use knowledge of a special right triangle. So if we have legs of 6 and 8, we should realize that we have a hypotenuse of 10 feet, and we can convert that to inches really quick. So that all we need to know now is the rate at which this hypotenuse is changing. So we know that we're dealing with a right triangle. We're dealing with 2 legs and a hypotenuse, so we're probably going to use the Pythagorean theorem. So we'll use, instead of a, b, and c, let's use x, y, and z. And we know that we're trying to find how fast the hypotenuse is changing, which is a rate. So we need to find the derivative. So we're going to take the derivative of this formula with respect to t. We're left with 2x dx dt plus 2y dy dt equals 2z dz dt. We make our substitutions. So we've got 2 times 72 times 2, 2 times 84 times negative 3, and 2 times 120 times dz dt. That's what we're trying to find. Okay, so we multiply, add, come to our left side here. So we've got, so that leaves us with 288 minus 504 equals 240 dz dt. Finally, we get negative 216 equals 240 dz dt. We divide both sides by 240, and we find that the hypotenuse is changing at a rate of 0.09 or 9/10 inches per second. I'm sorry. So that's negative 0.9 inches per second. So the strategy here, again, write down what you know. Try to figure out the formula that you're going to use. If you need to find anything else using the formula, find that first. Then go ahead and take the derivative. You're always going to take the derivative of the formula, and realize that everything has a measurement and a rate. Alright, you're probably going to be left with one thing to find, so you should be able to fill in all of the other variables. Alright, let's move on to the next one. Consider the curve given by x squared plus 4y squared equals 7 plus 3xy. And I couldn't get this to copy over, but it says to show that dy dx equals 3y minus 2x, all divided by 8y minus 3x. Okay, so we're going to derive implicitly. So we'll go ahead. 2x plus 8y dy dx. We're taking the derivative with respect to x, so when we take the derivative of y, we need to make sure we include the dy dx. Equals 0 plus, and we have product rule here, so we've got okay, so now we're going to combine all of our dy dx's on one side, and we're going to put all of our other things, other terms on the other side. So I'm going to gather my dy dx's on the left. I'll have 8y dy dx minus 3x dy dx. So they just take the term. It's going to end up over here by subtraction, and so we're just going to basically change the sign. Equals, you can drop out the 0, 3y minus 2x. So you can already kind of see the makings of our answer here. We're left with a factor, dy dx, 8y minus 3x equals 3y minus 2x. And finally, we divide both sides by 8y minus 3x, and we get 3y minus 2x all over 8y minus 3x. And indeed, we've shown that that is the derivative.